Hello and welcome to my YouTube channel Statistics with R. In this video, we are going to see how to perform regression modeling. Regression modeling aims to establish a relationship between dependent and one or more independent variables. In this video, we are going to see how to fit simple linear model, how to plot regression line, how to go for regression diagnostics, how to use the model for the prediction, and how to fit multiple linear model. This is the data set which we are going to use in this video by taking yield as our dependent variable, plant height and plant population as our independent variables. We will import the data into the R by using this script. As you can see, the data is imported into the R. Now, before fitting the model, we will try to visualize the relationship between the yield as a dependent variable and plant height as an independent variable by using the plot function. But before using the plot function, we will first attach the data with the data name is sample. We will use the plot function by putting plant height on the x-axis and yield on the y-axis. After running the script, as you can see, a diagram which is known as a scatter diagram is produced. As you can see, with the increase in the plant height, the yield is also increasing. That means there exists a positive relationship between these two variables. After visualizing the relationship, now let's fit a model using a LM function. LM stands for linear model. By taking yield as a dependent variable, then tilde sign, then we will take plant height as our independent variable. The next argument, we have to mention the name of a data which we have stored in the sample. We can store this script into an object called model. After running the script, we can check the summary of the object by using the summary function. We will use summary function, and within the parentheses we will keep the object model. After running the summary function, as you can see on the console portion, the output of the regression model is. First, we have to check the significance of our regression model by checking the value of f along with the value of p. As the value of p is less than 0.05, it means our regression model is statistically significant. Along with that, we are checking the value of multiple r square, which is one of the criteria for the model evaluation, and the range of the r square is 0 to 1. 1 stands for the model is a good fit, and 0 stands for the model is the poor fit. After, we can check the estimates of intercept and the estimate of a regression coefficient, which is also called the slope. As you can see, the value of the regression coefficient is 2.20, and the p value associated with it is 0.02, which is less than 0.05, which means the plant height has statistically significant influence on the yield. Now, after seeing the summary of the model, now we will try to plot the regression line on the scatter diagram. We will again use the plot function by keeping plant height on the x-axis and yield on the y-axis. Then after running the plot function again, we will use AB line function to plot a regression line on the scatter diagram. And for the AB line, we have to use two numeric values. The first numeric value which we have to put, it's the value of intercept, and the second numeric value is the value of a slope or regression coefficient. So the first argument is 1.22, which is the value of intercept, and the second argument is the value of regression coefficient, which is 2.20. After running the script, you can see a regression line has been plotted on the scatter diagram, which is a clear indication that there exists a positive relationship between two variables. We can also change the color of a line by using the color argument, and we can also change the width of the line by using LWD argument, and it is a numeric value. You can range it the numeric value from 0.1 up to 10. After running the function, as you can see, the regression line now is now in the bold color with a larger width. So this is how we are fitting, and how we are plotting the regression line on the scatter diagram. After fitting the regression line, we will see now whether the assumptions of a regression line whether the assumptions has been fulfilled or not by using the plot function. Within the plot function, we will keep the name of the object as a model which we have fitted previously. After running the function, as you can see on the console, that we have to hit the enter to see the plots. First, we will enter the enter. The first plot you can see is the residual versus fitted plot, which says us about whether our model is linear in nature or not by drawing a plot between residuals, which is a difference between the observed values and the predicted values, and the fitted values are basically the predicted values. And to be the model in linear in nature, this red line should be exactly running parallel to the x-axis. So this is one of the diagnostics which we are using to see whether our model is linear or non-linear in nature. Now we will hit again on the console portion to see the next plot, which is called the QQ residual plot, which tells about the normality of the residuals. These residuals should be exactly coinciding on this QQ line. As you can see, some of the residuals are far away from the QQ line, which means maybe probably this residuals are not normally distributed. For to be residuals to be normally distributed, these residuals should be coinciding on this QQ line. So this is the second diagnostic plot. The third diagnostic plot, by hitting the enter, you can see the scale location plot, which tells us about whether the variance is homogeneous or heterogeneous. For the variance to be homogeneous, this red line should be moving exactly horizontal to the x-axis. As you can see in this plot, it is moving horizontally, but it is showing some trend in the red line. So we can see there's a heterogeneity in this model. We can run the 4 diagnostic plot by hitting the enter again, and you can see this plot is a residual versus leverage plot, which will tell us whether there are some residuals, which we call them as with the outliers, or we will be having some leverage points. Those points can be the influential data points, which can be affecting the summary output of a regression model. As you can see, the Cook's distance is one of the major, with the help of which we are seeing whether we have our outliers and leverages in our regression model in or not. As we can see, we have the leverage that might be having the influence on the output of a regression model. So this is how we are checking the regression diagnostics of a regression model. We can also produce all these 4 plots in the one frame by putting the parameters of a graphical device. So the parameters we will keep in a graphical device by the power function. Then we will run the function mfrow is equal to c 2 comma 2. 2 comma 2 stands for we have the 2 rows and 2 columns, because we are producing the 4 plots. So first we will run the parameter function, then after we will run the plot model function. As you can see, all the 4 plots are in now one window. Now it's very easy to explain all the 4 these diagnostic plots to check the assumptions of a regression model. After checking the regression models, now we will be proceeding to how to use this model for the prediction. Before prediction, let's suppose we want to predict the yield for the plant height. Let's give some random values of a plant height, and we will store it into a new sample data, and we will make a data frame of those sample points. So our variable is plant height, so I will give the random numbers for which we are going to predict the yield. Let's suppose 0.5 comma 0.6 comma 0.7, and I am storing the newest data into the new sample, so that we can use these data points to predict the yield at these particular 3 points. So to predict the yield, we will use a very generic function which we are using is the predict function, which is available within the base package states. So the first 2 argument for the predict function is we have to give the name of the model object. Then we have to give then another argument is the new data, and we have stored the data for which we are going to predict the yield is we have stored a new sample. So we are going to write here new sample. So when you will use the predict function, you will hit enter, you will run the script. As you can see, for the first point 0.5, the model is predict the yield of 2.32. For 0.6, the model is predict the yield of 2.54. For 0.7, the model is predict the yield of 2.76. So to predict, for the prediction purpose, we will create a separate data frame, then we will put it under the new data argument. We can also produce the predict function we can use. Then we will keep the object model, then we can give the interval as a confidence if we want to give predict the model with some 95% confidence, which is by default set. So we will run the function. As you can see, after running the function, that these are the data points for which we are basically the model is predicting. So the model is predicting for the first observation 2.37. As you can see, for the first observation, the observed value is 2.47, but the model is predicting 2.37. And this prediction is having the confidence limit 1.95, which is the lower limit, and 2.79, which is the upper limit. So these are all the observed values which is in our data set, and this is what the model is predicting for all the data points. So we can be using two functions. One, the predict function, if we want to predict the yield or predict a dependent variable for out of the sample observation, or this is the function you can use if you want to predict for the observation on which we have fitted the model. Now after that, we are going to now fit a multiple linear regression model where we can take one more independent variable into our model. Let's suppose we want to save that model into model 1. Then we will use again the lm function. Then we will keep our response variable or dependent variable as a yield. Then the first independent variable we will put is the plant height. So, if we want to add another variable to the model, we will use the plus sign. Then we will add our one more independent variable, which is the plant population, and the name of the data, which is it is the sample data. So after putting all these arguments and data, we will run the model, and after running the model, now you can check the summary statistics of the model by using the summary function. But here the model object is model 1, because in model 1 we have given two independent variables and one dependent variable. After running the script, you can see in under the on the console part that we have got the regression coefficient of plant height, as well as we have got the regression coefficient of the plant population. Along with, we can also check the significance of a regression model by using the f value, and you can see the p value is much less than 0.01. It means this regression model is highly significant. This is how we are performing regression modeling in R. Thank you.